So here's the project that I've been working on, I'll tell you about. It's a VR world building app where you create and modify the environment with a bunch of tools that you see down there. You have some advanced building tools like wall making, for example. And I gotta make sure I don't have a mic on me. And lately I've been getting into some visual node-based scripting in VR. So you see I have a door, I can put this button down and say that button controls that door. There you go. You can also do some more kind of abstract nodes, like this one controls level switching and that kind of thing. So anyway, input is the main topic here. So first off, I'll just kind of run through a lot of main hardware, most of which I've developed with, some of which I have not. And then I'll go into how I support all this stuff in this project, mainly about dealing with input from all these SDKs, managing all the SDKs in the project, and how I've approached UI. So all the hardware. Of course, we got our headsets, the main ones here. I'm not sure if you can see the PSVR off to the side. It's grayed out because that's the one I haven't got to play with yet. But for anybody who's not familiar, on the top we have the Vive and the Rift, both of which tether to a PC. Vive's about walking around with hands. Rift is about sitting or standing. And then on the bottom we have the ones that you slap your phone into, and they have some form of input on the headset, which the top ones do not. So on Gear we have a 2D touchpad and a button, and on Cardboard we just have a single input, which for the record, oh, hey, thank you. For the record on Cardboard, generally you can't rely on anything more than just a click down. You can't really count on doing a held action or a released action on Cardboard, so keep that in mind. All right, as for controllers, we have a few main kind of categories of controllers, namely wands, like you have with the Vive controller or the Hydra or the Stem, and then at the bottom grayed out because I haven't gotten to play with them are the Oculus Touch and PS Move. And notice the commonality between all of those is all of them are pretty high accuracy, physically tracked objects that have some buttons on them, some sort of touchpad or joystick, and some sort of trigger. So that's what we're trying to abstract there. And then it gets weirder as you go out and you have optical trackers like the Leap, where you're not holding a controller, you just have your hand there, as well as some mobile controllers like the Nod Ring, for example, that you just wear on a finger and it does some positional tracking and has a few buttons on it. And of course, good old gamepad, traditional input. So the question is, how do we make all of these things talk to our app in the same way? Or at least that's the challenge that I have decided to tackle here. And namely, how do I get something like a super high precision wand that has a bunch of buttons on it interoperable with something like a Leap where I have no buttons and relatively less precision? And then of course there's also AR stuff, like handsets like the Tango, as well as headsets like the HoloLens and Meta there. So I'm going to try to work with as many of these as we can. So the real topic here is how to deal with that input. And namely, I'll be talking about how I deal with that input in Archean, my project. And I should mention this is very Unity-focused and C#-focused, but these concepts should also be applicable to whatever platform you're working in. So at a high level, this is what the input code base for Archean looks like. There are kind of two main frameworks. One is tools. So that, again, is, as you saw in the video, I have a bunch of tools that the player can use. Where they pick a creation tool or a move tool or a wall building tool or something like that, and then they interact through that tool, or there's just a more general input framework. So the first part of all this is the SDK-specific binding scripts. So you're always going to start with, at some level, you need to have a script that is talking to each piece of hardware, each SDK. You definitely don't want anything that is project-specific in here. No gameplay code, nothing that is directly tied to your project. You should only be dealing with input at this level and input directly from the SDK and sending that up the chain. So what you are doing is you probably have an update loop where you're listening for a button click or a fist closed on the Leap or something like that, and you're sending out the frame down, frame up, and all the held frames in between up the chain. So first we'll go into the tool framework here. When I pass any input through the tool framework, I send it through this input components object. And what that does is keeps track of anything about that device that I might want to know, like its position and its direction, and anything that is device specific. So it starts at that device specific level where we have, for example, the Vive controller components will have a reference to which Vive device this object is. And that is again, SteamVR SDK specific attribute. But you notice that is extending wand components, which is a category-specific class. So this is going to have anything that any type of wand, so again, that could be a Vive controller, it could be a PS Move, any device like that. They're all going to have some transform in the scene, which is just where that object is, what the object is in the scene. And then I'm also going to be able to get from that object where its position, its forward direction, and what its current rotation is. You'll see all of those are overrides coming from the input components class, which is just the base level, most abstract class. And this is just what I need to assume any device is going to give me. So that would be things, again, like position and forward direction. And notice that not every single device actually has a position and a forward direction. Like a gamepad, for example, doesn't have any tracking at all in most cases. So in those cases, I just fall back to head look. I say, where's the user's head and where are they looking? That's what I'm going to use for those attributes. And you'll see why. So that gets passed into the tool base class, which is the thing that actually handles the tool has been pressed, tool has been released. And it starts again at a SDK-specific level where I'll have a hook for each object. So I'll say, a 6sense controller has been clicked, or a leap hand has made a fist and been clicked, or a tango has been tapped on. And then those will all forward their components into a category-specific hook, like a tool has been pressed for a wand, or for an optical tracker, or for a point cloud tracker. And then those, again, will just abstract further out to just a core function that says a tool has been pressed with some object, go send it the information I have about this object. So the core functions that I have are again, frame down, frame up, and then I have a just loop for tools being held down, and another one for tools being displayed, so it shows some visualization of what this tool is going to do. And then there are some special cases like this do tool down and hit. Let's look at where that comes from. In the do tool down, I just do a raycast there from whatever input's position and forward, and if it hits a valid layer, which is usually going to be terrain or another entity in the world, then fire off that, I have hit something hook. So this all culminates when we actually get to a specific tool, like a tool that's going to move something or a tool that's going to create something. So let's look at one of those. Here's the move tool. It's effectively a one-line script. It just says when the user is holding a tool and that tool is hitting the ground, then move the selected object to the hit point. And notice that one line there, selected trans.position equals hit.point, works on every platform. So that could be a Vive where I'm pointing a wand at the ground. It could be a cardboard where I'm looking somewhere and clicking the button. Or it could be a Tango where I'm in AR mode and I'm pressing somewhere on the point cloud. So that's what this is really all about, is being able to have a single line script that can handle just any device you throw at it. And if I write a new tool, I don't have to add support per tool per device. If I add a new device, I don't have to add any support throughout the rest of the program for that once I just stick it all into this framework. So that's the real bread and butter here. And then, of course, you can do more specific behavior than that. If I don't want to say, OK, any device I'm using, it's just going to throw it at the hit point. I may say, OK, that works well for a wand, or it works well when I have head tracking, but it doesn't work so well when I'm using a leap, for example, if I'm doing optical tracking. It just doesn't feel as good in my experience to be pointing around with my palm and then kind of clicking. I'd much rather be able to grab something and then push and pull it when I'm using a optical tracker. So in that case, I would override that specific hook for saying, OK, if I'm using a leap, then do it differently. And of course, you could also say you're using Oculus Touch, where it is a wand controller, but it also has capacitive surfaces on it. That's how you would add some SDK-specific, device-specific behavior, where I'm saying, OK, it's going to be like a wand, but also it has this extra layer on top of it. OK, so switching gears out of the tool framework there, which again, that is kind of specific to my project because I have this concept of users use tools, to the more general case where it's just kind of gameplay code going through the general input framework. Again, it starts with the SDK-specific classes, and then those will forward their information to just the hardware input base class, which is the base of all those SDK-specific classes. And like I said, this is good for any time that I don't want things to go through tool, and is good for any kind of one-off interactions or general gameplay code I want to use. So for example, if I have a lever in the world and the user is going to pull on that lever, I don't want to make them go use a tool for pulling on levers. I want them to use just reach in, pull a button, pull it down. So this would be one of those cases. And I have a couple of different ways to do it, a few different ways to do it. One is very familiar to Unity's input API. So I just have a HardwareInput.button A down, or held, or up. So very much like input.getButtonDown. And notice, of course, button A is kind of a weird term because not all controllers have an A button. So it's kind of up to you to decide, OK, on a Vive controller, the A button is the application button. And on a Leap, an A button is a clicking of my fist. And then I have a event-based system for if I just want to listen for that event to fire, when I say just wait for button A to be pressed without having to do that in an update loop. And then just a centralized static void where I say, OK, I can put all of the gameplay code or all the input handling code into this one function in hardware input. So it just kind of depends on what works for the case that you're working in. So for a specific example of that, if I'm going to go write a gameplay class, it might look like this, where I just have a one-off mono behavior, and in update, just like the normal input API, I'm just listening for, has the trigger been pulled? Or then in awake, you see there I'm using the event-based way of doing it, where I say, go hook into the handle button A event, or sorry, the on button A down event, and just listen for that and respond to it. So that's really good for something like a tutorial where I'm like, hey, go press the trigger to activate this menu, and then I just want to listen for the user doing that at least once. I should also point out here that I'm using this world console.log. This is kind of sideways to the talk here, but I have found this really useful to have a text box in VR that I can actually see when I'm in the headset that I can print stuff out to and write console commands into. So that's what the world console is there. And if you're not doing that in your project, I'd really recommend it because it's much more convenient than debug.log in VR. And of course, you can also pass input components along with this if you want to get that same position and forward and all that information that you saw before. In the general gameplay input framework, just pass the input components object with it. And then those three approaches would look like this now, where the normal input method where I say, is button A down, I could then also have a query for .position or .forward. So if I'm using a Vive controller and I click, then not only am I going to go say button A is down this frame, but also I'm going to pass it that component. And then in the event-based way, I would pass the component through a event args object. If you're not familiar with that, if you are doing events in C#, you can pass a specific kind of object with an event, which is a event args. Then you just put whatever you want into it. And then, of course, the static void method, you just pass it as a parameter. Easy, easy. OK, so about actually handling all of those SDKs in the project all at once. First off, they all are in the project. That's the quick and dirty answer to it, is that there's just a folder there that has all the SDKs. So I have Cardboard, Gamepad, Leap, Nod, Hydra and Stem, Vive, and Tango, all sitting there in one project. Notice, don't call it library, because you probably have a git rule set up that will ignore the library folder, and it might also conflict with Unity's library folder, so don't call it library. There are some problems that come with this, of course, namely with Android SDKs. Sometimes they'll conflict, namely the Android manifest files, but you'll have a bunch of other kind of plug-in collisions sometimes. There are cases where it's pretty easy to deal with this, and you want to, like when you're using a Cardboard and a Nod ring together. Like that's a really good combination. And you just have to kind of go manually merge that manifest file. But in some other cases, for example, if you're using Cardboard and Tango, those two don't really mix right now. So you'd want to get one of those SDKs just out of the project when you're trying to make that build. So you could do that manually, just say, OK, when I'm going to make a build, I'll keep it in mind, I'll take the SDK out. Or you can hook it into the build pipeline where you say, when I'm doing a Cardboard build, go move, make a script that will go and move those files. Or you could have an editor tool that will handle it, which is actually what I've done. The scene itself has the components for all of that SDK support in the scene all the time, just on the player object in my case. So if you look at the player, it has components for Vive, for Gamepad, for Cardboard, for all that stuff just sitting on the player. And that's great because it means that, in my case at least, I only have one scene. So that's really nice. I don't have to kind of manage a bunch of scenes and duplicate a bunch of work between them. It also has the added benefit that you can have multiple types of devices working simultaneously. So I could have a Vive wand in one hand and a Leap tracking the other hand and be able to let those interact, which is super cool. But it's also complicated because that means that there's a whole kind of world of design challenges. OK, did I count on a Leap hand being able to interact with my Vive interface? And also technically, there's a lot more ins and outs to deal with there. It also means that things are going to get more complicated the more inputs you have. So you're going to have a more complicated scene or more complicated player prefab or wherever you put this. You could deal with that by splitting the player or whatever object has all these inputs in it up into different prefabs, then assemble those as you need them. Assemble those at build time or at editor time. I have opted not to do that because I find that just more complicated. I'd rather just see all the components there all the time and be able to manage it more easily without having to piece them all together all the time. And I have an editor script here where I can say, go set it up for Vive, set it up for Rift, set it up for Gear. So whenever I click on one of those, it'll just disable some components, enable some other components, move some files around, and kind of have the build ready to go with that and not be running any totally unnecessary components. Again, it's a little hard to say sometimes because you might want, for example, Rift and Leap working at the same time, or you might not. Right? Maybe Vive and Leap is a better example since you already have controllers there. But I've found it very useful just to kind of leave some of those extra properties running. The script that I use to actually activate those is super simple. I just go through and say, turn this camera off, turn this piece of UI on. As a added bonus, I like using name parameters in cases like this, so this function doesn't just look like false, false, true, false, false, true. That'd be really hard to read. So instead I just have that named explicitly. And then a few words about how I've handled UI in this project. So I have not used UGUI. I've done a pretty basic just raycasts and colliders approach to UI. And why not UGUI? Long story short, it wasn't stable when I was starting the project, so I just started going down this path and have stayed on it so far. But if you are using UGUI, then UGUI being the new Unity UI system, then you're going to want to write an input module for each new piece of hardware that you're supporting. So if they don't have support yet, you just go write a new input module, plug it in, it works. So in my UI, the two main kinds of interactions that can happen are either you're kind of pointing at a button at a distance and clicking on a button, and that's great for wands or gaze-based interactions, or you're directly clicking on a button, which works really well when you have tracked hands, optical tracking with a leap or something like that. And that's what the button component looks like. I just have, button object sits there, and I have a string action of what it does, and you'll see how that maps in a second. And then I can add a bunch of options onto that and link it to a bunch of different objects. And there's just a big, huge switch statement in one script that handles all of the GUI interaction in the whole program, which just says, OK, which string is on that button? Go send it off to a different function. And to go along with that, there's a file that just has a big list of constant strings that will be all the different strings that I can use in the GUI. Just makes it a little easier to keep track of what is there, make sure you don't have any typos, make sure that you can always go do a find references on any of those. So very convenient. So like I showed you on the component, you can do some more advanced functionality by kind of adding parameters through those string and int and object fields. And you can add just a big list of strings if you want, so you can have a whole bunch of different stacking parameters. And I've actually really preferred having all the UI code centralized. Like I said, I have this big switch statement that maps all of the different strings to different functions. I find that more convenient than actually using the UGUI method where I have a button and I attach a specific function onto that button. Just because it is all in one place, I know where I can look to find all the UI code in the project, which is nice. And also, it can pass any sort of data type, whereas UGUI has some specific data restrictions. OK, so if you are thinking about making a multi-platform VR app, my first question to you is, are you sure? Much wiser people than myself have said, pick one platform and just really dig into it. And that's really good advice. Like you've seen here, this is a lot of extra work. This is kind of a work multiplier when you're adding this multi-platform support, because you can just never count on OK, I know for sure that the user is going to be holding a thing that has some buttons on it and they can point at a spot. It's much easier to develop if you know that kind of thing for sure. The other kind of drawback of this approach is that it makes it much harder to really dig into really SDK-specific functionality. So for example, if I wanted to integrate Oculus Social into this project, well, then that branch would be Oculus-specific, and then I'd probably want to duplicate that work across the other social APIs that are available. So again, really think about it. I mean, I'm still very happy. In retrospect, I'm really happy that I did this with this project. It's been very cool to be able to work through that challenge of using all the hardware. But again, there are a lot of benefits to picking one and sticking with it. Also be aware that the Steam VR native Unity VR integration is forthcoming soon. It's in beta right now. Cardboard is coming soon after that, I believe. So if you're not starting right now on a multi-platform project, you might want to wait another month or so and see what happens. But the really big point is that this is definitely something you want to plan on doing from the beginning of the project. You want to know at the beginning, OK, I'm going to make this work on room scale and gear and AR. Because it's way harder to do this in retrospect. It's way harder to go back and kind of undo some assumptions you've made about the user's always going to be holding an object or the user's never going to have a controller than it is to build it from the beginning. Because you're going to have a lot of kind of design considerations where every feature that you add, you have to say, OK, how's this going to work with a wand? How's this going to work with an optical tracker? Whereas if you're designing from the beginning, you know that for sure. If you're not, then you're going to make some assumptions and get in some hot water there. So yeah, long story short, I'd say go for it if you know for sure you want to do this, knowing what's involved, and plan on it from the beginning. That's pretty much what I got for you today. So do you have any questions? Thank you.
So great talk. Really enjoyed it.
Where are you?
Now, it occurs to me that a lot of people in this very room are probably going to be building something very similar to what you've already built. Have you thought about putting it into the asset store?
You know, my buddy's giving me feedback yesterday, guaranteed that would be the first question. So thank you. Potentially, I'm seeing where this is taking me right now. Definitely one option is putting on the asset store as just a multi-platform framework. It's also, like I pointed out at the end there, this is something that is going to become easier in Unity than it has been so far. So it's also going to kind of depend on how Unity ends up handling, for example, wand controls, because right now the Steam VR beta integration, for example, works with the headset but doesn't work with the hands. So as far as we know, there's still not any real solution there for how we're abstracting hands versus tracked hands versus tapped hands. So I think it kind of depends on where that goes. But yes, I'd be interested.
Just to follow up, I think it's probably going to be months or maybe even a year before Unity has that all really sorted out. So in the meantime, that kind of asset would be useful.
Totally. No, that's a good point. Thank you. Definitely consider it.
Hi.
Hey.
Have you had any issues with the ordering of scripts, how they are executed?
Yeah, so script execution order, definitely something I could have mentioned in here. Basically, the big one that comes to mind is anything that you have the kind of bool callback there for is button A down thing that I mentioned. You're going to want to have that, the very first script in the project is going to set that to false. Any SDK-specific script along the way that happens between the beginning and the end of the script execution is going to set that to true when its button gets pressed. And then in a late update, probably on the last script that gets run, you're going to turn it off again or just wait for the beginning of the next frame. So yeah, that's kind of the main consideration. Other than that, you have to think through, like I mentioned with the having a wand and a tracked hand, you might have to think through how are these going to interact, and does it matter if one input comes before the other one in the frame? But I haven't had any real issues with that kind of thing.
Thanks.
Thanks. Anybody else?
Hi there. Thanks for that chat.
Oh, thank you.
I was just wondering, in terms of maintenance of keeping your SDKs and everything up to date, have you found any best practices around that? I've made systems similar to this.
Yeah.
And I found after a while you spend a lot of time just having to keep everything up to date and repairing maybe changed APIs and things like that.
Yeah, that's definitely a challenge. You're totally right about that, especially in the last year or so. It's been very dynamic. SDKs change a lot. One of the big things for me has just been most of these SDKs have a GitHub account somewhere, and I'll just subscribe to the email chain there so I can see, okay, there's been a big push, there's been a big change to how they handle things. I mean, usually the actually getting a button input, that kind of thing, the sort of stuff that I'm talking about here usually doesn't change that much because it's so fundamental. But yeah, you're right. That is definitely something to watch out for. And like I mentioned, if you're going to make a multi-platform project like this, it is a lot of work because of that kind of thing where you have to keep going back and making sure that things still work.
Cool. Thanks very much.
Yeah, thank you.
Hi, thanks for the talk. I really enjoyed it. I had a question about, did you have to limit what you thought about doing in your game to support the sort of variable tracking modes across the different devices, and sort of whether it's room scale, and even how you thought about locomotion in terms of it when it's so diverse?
Yeah, absolutely. I mean, you're hitting the nail on the head there that it is a big design challenge. I mean, I didn't really get into any of that in this talk because I was trying to focus on the technical side, but absolutely there's a huge design space happening there where you're thinking about, okay, when I'm in a Vive, I'm going to be able to walk around the room. When I'm in a Gear, I'm just maybe going to interact with stuff right around me or maybe teleport between rooms. Generally speaking, teleportation is kind of the main piece of locomotion that most of us have come up with. So that at least works on all platforms. Then we can say, okay, and then if you're on a Vive, you can also walk around from that teleport point. I have done a lot of specific pieces of content where it's like this piece of content only works in room scale, or this one really is designed for more of a sit-down experience. So that kind of plays to the nature of this project, which is content building, so it makes it a little easier to deal with. But generally speaking, you do kind of want to go for the lowest common denominator of like, okay, does this work in a seated experience without a controller? Everything else is kind of sugar on top from there.
Thank you.
Thanks. By the way, I talked a lot about locomotion at Vision Summit, so look that one up on YouTube, and it's all room scale locomotion stuff. Thanks.
Hi, great talk.
Henry, what's up, man?
Hey. With so many different kinds of input devices that you can use different combinations of, I was wondering if you had any thoughts about how you sort of schedule time to test all of them and prioritize which ones you're going to test, what combinations.
To be honest, that comes down to how excited I'm feeling about different platforms day by day. It tends to be the ones that get the most testing. And other than that, sending builds out to friends, that kind of thing, is like, hey, who wants to play with the cardboard build and tell me what's broken? But most of this stuff, I guess, again, because of the nature of the app, most of the stuff I can kind of run through a test in a minute or two and just say, okay, do all the tools work? Go through a few different levels. Does the content work in most cases? Or at least, am I not assuming that one piece of content is going to work for a platform it wasn't built for? But yeah, again, that is a challenge of doing this kind of thing, for sure.
Thank you.
Thanks.
Hi, good talk. I kind of make this kind of stuff in my company too, and one of the challenges we faced is submission guidelines of various platforms. For example, the Gear VR has guidelines for say the back button has to go back to the universal menu,
right?
And the PSVR has specific requirements, stuff like that. In the end, for time's sake, we bumped into this in the end, and we had to make different branches of different platforms. But I was wondering how you would approach something like this.
Yeah, I've also ended up making a bunch of different different branches for different platforms to go and deal with specific cases like that on specific platforms. Generally, I do then just try to merge everything back in and try to make sure the master branch actually observes all of those different conventions and all those different requirements. Yeah, I can't say there's any specific thing that I've done to really deal with that kind of thing, other than just having, in some cases, some specific components that are set up for one particular platform, and I say, okay, when I'm on Gear, make sure it behaves this way, and then it's really just a matter of keeping track of that. Just we have to know those things and say, okay, what do I have to make sure it works on Gear? What do I have to make sure it works on Rift? That kind of thing.
Okay. All right. Thanks.
Thanks.
When you're doing the multiple input devices, when you're looking at multiplayer, is anything you need to keep in mind for that sort of on the SDKs and such?
So I haven't done too much multiplayer yet. The multiplayer of this project is still pretty rudimentary. But
the main advantage to this is you're allowing people on different computers to play with different devices.
Right, for sure. Yeah, my main approach to multiplayer has just been whichever device I'm representing, whether that is the wand in one hand and a leap hand in the other, just those transforms are going to be network synced. So I say instantiate my wand when I start using that object and sync that with all the other players. So yeah, any combination you're using, as long as you're always syncing all of those input devices, it should work fine in multiplayer. But again, I've done only a bit of testing multiplayer so far. I think we have time for one more, but I'm not sure if we have one more. We have one more.
So at least for the wand, you didn't talk about changing the 3D model in the scene to represent necessarily the Vive controller or the touch or your hand. Right, yeah. So let's see, how does that work? I'm trying to remember back to it right now. Yeah, I know, you know. Yeah, so each of those objects does have a specific component on it in the player object where it says, which hand am I using? Go engage that object. When I start using a Vive controller, it's going to go turn that object on. Or if I'm using a Hydra, it's going to go turn that object on. And then each of those could just have their own specific meshes in there. Follow up?
And then what part of, does that go in the hardware layer or the tool layer or the...
That goes in the scene setup layer, where just, whichever SDK I start using, it's going to go switch that object on.
Cool.
All right, I think that's it, everybody. Thank you for coming. Have a good day.